Welcome. My name is Thomas Hillen, and it's a great pleasure to interview today Adrianne Jenner at Queensland University of Technology in Brisbane. So Adrianne, just introduce yourself just quickly.
Okay, my name's Adrianne Jenner. I'm a senior lecturer here at Queensland University of Technology, or QUT, based in Brisbane. And my area of research spans a few different things in math biology, but mainly math oncology and immunology.
Wonderful. So have you always been in Brisbane? Are you from here?
I'm actually not from here originally. I'm from Australia, but I'm from an area south of Sydney, which has the whitest sand in the world, also called Hymes Beach, if you've heard of it.
The whitest sand?
Yes, whitest sand in the world. I grew up by the beach, surfing, or at least I was an okay surfer. And then, eventually moved to Sydney, Montreal, and then to Brisbane.
Okay. So where did your education take you?
So I started my undergrad at the University of Wollongong. Wollongong's a city just a bit south of Sydney. I did a Bachelor of Math and a Certificate of Languages in French because I just really liked math and French when I was growing up.
Okay.
And then I did my PhD at the University of Sydney, and then did my postdoc at the University of Montreal with Dr. Morgan Craig, and now I am here in Brisbane at QUT.
Yeah, so I had the chance to meet you when you were a student,
Yep.
a PhD student,
Yeah.
right? So many years ago.
Yeah.
No, not so many years ago.
Well,
And,
almost 10 years now.
So when did you get interested in modeling cancer?
So I would say that was thanks to my PhD supervisor. When I finished my Bachelor of Math, I just really didn't know what to do with myself. I just really liked math, but I didn't know the point of it. So I left and I became a travel agent, but I was really unsatisfied with being a travel agent. And eventually I met Professor Peter Kim, who's at the University of Sydney.
Okay.
And he had a project in oncolytic virotherapy, which is a type of cancer treatment that uses viruses to kill off cancer cells. And I was just so excited by this idea that math could be used to help study cancer and help improve the way we treat cancer, that I was just immediately hooked and has pretty much just continued that journey ever since.
Oh, interesting. So
Yeah.
are you still working on oncolytic virotherapy?
I do a little bit of work still on oncolytic virotherapy, but I have branched out into a few other different types of cancer treatment, but still do get to work with virotherapy, which is interesting.
Yeah. So now, Adrianne, I know that you are currently in maternity leave, so
Yes.
thank you for having time to talk to me anyways. But,
Yeah.
but of course, it's a great opportunity to talk to you about the role as a woman in science.
Yeah.
And in particular, the challenge then of raising a child. So.
Yeah, I think, so my son, for context, is 4.5 months old. So I'm 4.5 months into my maternity leave. This is my first time away from him, which is both exciting and nerve-wracking.
You didn't check your phone for 5 minutes?
I did just check if he was asleep, and he is asleep. But no, it's given me a new perspective on what the challenges are of being a parent or a woman in math, particularly raising a child, because I think as researchers and mathematicians, it's so much ingrained in our identity. And when you have a child, often you lose a little bit of that identity. And so it's been really wonderful to be able to come in and work with Thomas on my maternity leave and be supported by Thomas and the university to, I guess, give me the opportunity to do that. It is a challenge. It's definitely a challenge.
Yes.
I didn't appreciate until I had a little kid. But he's a good little boy.
But of course, before you did this, you knew already about opportunities to take maternity leave,
Yeah.
for your husband to take maternity leave. So this is encourage you to?
Yeah, definitely. I feel like I feel very supported by our community,
Wow.
particularly the math biology community and my school here, the School of Mathematical Sciences. I feel really supported to have a family and return to work. There's lots of initiatives for me. So for example, I actually went to a conference in February. I don't know if I told you this, when my son was 8 weeks old.
Wow.
And the conference
Yeah.
supported me with a babysitter that was in the room next door to the conference venue. So I could just duck in, feed him, duck out, watch a talk or network, and then duck back in. And that was just incredible. That was such an invaluable experience to me, to be able to
Interesting, yeah.
stay involved in my community, even though I was on maternity leave. And that might not be an option for everyone. Not everyone might want that, but to have that option for me was really, really, really great.
There can be a decision maker, right?
Yeah.
If you go to a conference or not.
Absolutely. And my husband came and he supported me as well. And everyone was really understanding in our community, in the math community, that I was there. Yeah.
That's good to hear. Yeah, and Ricky is absolutely awesome.
Yeah, Thomas got to meet him, so that's good.
Last
He's
week.
come to a lot of our math meetings, hasn't he? Sorry, he's not here right now.
Yes. Let's come back to science.
Yeah.
So I realized that we are kind of at a change a little bit in how we do mathematical biology. So new methods coming about, new data coming about. So
Yeah.
what's your feeling about this?
Well, I feel like it's really exciting. I think I've moved from using just data with ODEs to using now data with agent-based models, which
Yeah.
I find a really exciting new area. I'm still a little bit behind on the techniques, but I see what people are coming up with in the literature, and I think it makes me really excited that not only can we now develop these agent-based models that might look realistic and be one possible representation of the truth, we might be able to eventually calibrate them to data, whether it's spatial data or just time series data. I think that's really exciting to me personally.
Yeah.
So I'm really enjoying the agent-based modeling boom, and then also our ability to calibrate it to data.
So would this influence how you educate students? So I think you have graduate students, right, at the moment?
Yes, so I've got a few graduate students at the moment. Yeah, so definitely trying to get them to learn the new techniques to then help me to learn these techniques, which has been really great. Yeah.
Now, a lot of us also work with clinicians, in particular in the context of cancer modeling. So are you working with clinicians?
Yeah, so I have had the opportunity to work with clinicians over my short career in math oncology. So I got to work on this project. It's probably one of my favorite projects. That was with a group at the Harvard Medical School that looked at a brain cancer treatment using viruses, so using virotherapy.
Right.
And we created an agent-based model of that, and we're trying to just help them understand if there might be reasons the virotherapy would fail in different types of patients. And our agent-based model was able to suggest one possible explanation for that is the sparsity of the tumor cells. And so I really thoroughly enjoyed working with clinicians, but I also do a lot of work with experimentalists. I kind of enjoy the experimental side as well, working on really novel treatments that might not be at the clinical trial stage, helping biologists understand their treatments and make just the treatments better in vivo, maybe in the mouse setting.
So how do you get into contact with those people?
I guess there's a combination. Sometimes it's just going to conferences. So one of the best connections I made, I actually just went to a cancer conference, and then I saw a poster of someone where I was just so excited by the data they had. So I just went up and asked them. I said, "Oh, can you tell me more about your data?" And then I thought, wow, I really think I could use this data, and I think I could do something with it. And so we started collaborating. So as simple as that. It was just a matter of finding some data and then just talking to people.
But still, you find the initiative should come from you, right?
I mean, I kind of think so, yeah. I think, in my opinion, I know what I could do, what value I could give to somebody, like a biologist, but they might not be aware of what value I could give to them. So it's important that I go up to them and say, hey, your data, I've done something similar in this area. I think I could be really helpful here.
So your career started not so long ago, but still, they are younger people.
Yeah.
What would you recommend for young people to enter this area? What should they focus on?
Oh, it's an interesting question. So to enter math oncology or just enter math biology? Math oncology. Yeah. Okay. Yeah. I think the things that have helped me in my career was finding someone that I really clicked with to work with. I think more important than the institution is the individual. So I met my postdoc supervisor and we immediately clicked, and we really understood how to communicate with each other and could speak the same language, and it just meant our research really blossomed really well.
Right.
So I think when you're starting out and if you're interested in math oncology, I think reaching out to people, trying to meet them over Zoom or meet them at conferences and just having a conversation and seeing who you click with is my biggest recommendation. Because if you find a researcher or an academic you can talk to openly, I think the research will come from there. I think as mathematicians, we're having a major impact in the field of oncology already, and we're seeing impact at many different scales, at the clinical scale, but at the experimental scale. And I think that this will continue. I think the more people that get involved and the more we work directly with experimentalists and clinicians, the better that will be. I think we still have to connect everything we do mathematically with experiments. I think it's important that we don't just do fun math for the sake of fun math, although that's really, really important. If we want to have impact in oncology, we've still got to try and connect with the experimentalists and the biologists.
Yes.
And I think there's going to be a lot of interesting stuff coming out with immunotherapy still. I still think there's a lot of novel treatments coming out there. I know there's a lot of combination treatments with virotherapy that we've looked at that are really, really exciting. So I think the field will continue to grow, and I hope that mathematicians, we can just keep helping these clinical trials get better and better.
Yeah, I agree.
Yeah.
I think that's right. Yeah, very good.
I think one of the great things, like maybe about the female perspective
Right.
in math oncology, I think we've got such a really welcoming community in the math oncology space and the math biology space. And I think it's really important that we continue that promotion of equity and diversity, but also make sure that we aren't overloading women with committee positions. And I know that sounds counterintuitive, but I do find that because we want to have this diversity on panels for awards and committees, you end up sometimes being overloaded with these positions. So I think it's important that we keep striving for a balance in all areas, and that's one area that I think we still have to work on.
Yeah, that's so easy, right? Okay,
Yeah.
so we need 2 more women on this committee. So
Yeah.
why don't we ask Adrianne?
Yeah. And it's like it's so great. It's so important that we have diversity, but still striving for balance there is important.
Exactly. It's also workload, right? It's a different workload, and
And I think making sure that if women get an award, that they aren't made to feel like they got that award because they're a woman. I think there's still that underlying rhetoric that you have amongst some people that you've been awarded this because you're a woman and we needed to give it to a woman. And I think that's really important that we make sure that that isn't something that continues in not just our community, but all communities in math bio.
Sure, I can, so not much I can say about it.
Yeah.
So, right. Good, So then that's all the questions I had. So thank you very much for your time and for your interview.
Thanks.